Okay, so now we're going to talk about the properties of matter that we need math for. So the first thing we need to discuss is properties versus characteristics. Remember that characteristics are used to describe an object, like it's pink, it's big, and properties are used to identify a substance. So properties need to be much more specific, and that's where our math skills come in. So color, shape, size, density, texture. So general properties of matter include mass, weight, volume, and density. Okay, mass, weight, volume, and density. And all of those are measured and or calculated. Mass, remember, is the amount of matter in an object, and it is measured in grams. Weight is different. Weight has to do with the force of gravity on an object's mass. So weight changes, whereas mass does not change. So for instance, my mass on Earth and my mass on the moon will be the same. But my weight on Earth would be greater than my weight on the moon because the force of gravity is greater on the Earth than it is on the moon. So weight is not a very consistent measure, so we really want to use mass as often as possible. Volume. Volume is the amount of space that an object takes up, and it can be calculated or measured depending. One way that we calculate volume is to measure the length, the width, and the height, or to take measurements for length, width, and height and to calculate them, multiply them together. That will give us centimeters cubed, and most of you have done those calculations in your math classes up to this point. But everything is not a prism and cannot be calculated that way. So we tend to measure things that are irregularly shaped through a process called water displacement. And if you notice, we have one beaker on the left that measures a little over 10 milliliters, and then another beaker on the right that has a rock in it that measures a little over 30, or right at 30 milliliters. So that's how we determine water displacement. We take the measurement before the rock was dropped in, and we subtract that from the measurement after, and we know that the rise in the level of the water is the displacement of the rock, and so that will give us the volume of the rock. We use water because it is 1 gram per milliliter, so that makes it a very easy conversion, and also because water is not corrosive and it doesn't damage objects that you might be trying to measure. Density. Now, density is going to be a mass to volume ratio. So it is the amount of mass per unit volume. And it is going to be a derived unit because we're going to have to know both mass and volume in order to calculate the density. Again, I said water has a density of 1 gram per milliliter. Okay, so we judge a lot of things based on water. Is it denser or more dense, or is it less dense than water? Objects with densities greater than 1 will sink in water. So obviously, objects that are less than 1 will float. Okay. In order to calculate density, again, you have to know mass and volume. And so you divide the mass by the volume. So we get D equals M over V. But density has a special variable, a Greek letter rho, and that is this thing that looks kind of like a P. It's a Greek letter rho, R-H-O, and it stands for density. So you may see the formula as D equals M over V, or you might see it as rho equals M over V, and both of them are actually correct. We're going to use this triangle in order to calculate density, because density equals mass over volume. At the same time, that means that volume equals mass over density, and that mass will equal density times volume. So that's how we use that triangle. Now, let's do a practice calculation. If 96.5 grams of gold has a volume of 5 cubic centimeters, what is the density of gold? Okay, so we have this little thing that we use called guess. And so the first thing for guess, G, is given. So what is given in the problem? Well, the mass is given at 96.5 grams, and the volume is given at 5 cubic centimeters. The next thing we want to talk about is unknown. What is unknown? Well, density is the unknown. That is what we're looking for. Then we go to the equation. What is the equation? Well, the equation is density, or rho, equals mass divided by volume. Okay? Next thing we're going to do is substitute what we know. We know that the mass, 96.5 grams, over 5 cubic centimeters, which is the volume, will give us density. So we'll set that up. So far we have given, unknown, equation, and substitution. And then, of course, the last one will be solve. So we'll actually divide 96.5 by 5, and we get 19.3. Now, neither unit, grams nor cubic centimeter, will cancel. So we keep both units. That's called a derived unit, and it's grams per cubic centimeter is the answer. So that's how we calculate density. Now, you're going to do a worksheet, and this is